Good morning, good afternoon, and good evening, everyone. So today we're just going to be continuing what we were able to do earlier. I kind of did it already. Um, so that problem was that plane passing through the line of intersection of two other planes, and it's perpendicular to to another plane, basically. So what do we need when we want a plane? We want a point, and we want a normal vector. So the point is, well, we can actually get it through this line of intersection. It passes through this line of intersection, right? Okay, so um, we can say if z is 0, yeah, we can play around with these two planes here, these two planes, and we will get a corresponding x and y, so we get this point. So done, check, we have our point. Now we want to find our normal vector. How do we do that? Well, we need two vectors, and we want to get those cross products. So what are those two vectors? Well, we get the normal vector of the first plane and the normal vector of the second plane. And then we can get their corresponding, if we get their cross product, we will get a vector that's perpendicular to both n1 and n2 vectors. So how would that look like? I actually don't know, I'm gonna admit. Let's say this was the two planes, and then this is their line of intersection. And then I don't really know how to visualize the plane that we need that's passing through this line. I can't visualize that. So I'm gonna look at my notes real quick. Um, so the way to visualize, actually, I don't know. Uh, let's see. So for planes, okay. No, for intersection, maybe. Okay. No visuals yet. Okay. Um, oh, how this works. But these are two planes. How about another plane that's passing through that? I guess like another plane would be, actually we kind of did this in the one of the beginning parts here. Um, no, it just means it's intersecting. How would passing through look like? Yeah, that one's the weird part. But anyway, so we have that line of intersection, and let's just say it passes through. Don't know how it passes through. Actually, it should be on. So it could be like, I could say this line continues. I think our plane would be like, um, I don't know. Our plane could be like here. It's passing through. I think that's what it means. Yeah. Okay, but yeah, we have a point. We got that. Now we need a direction vector. So we just need to get the normal vectors of both planes, get their cross product so that we get a normal vector or a vector that's perpendicular. Then once we get that, we can just plug in safely. That's it. Visually, I don't know how that looks. Um, yeah, that's my only problem. Anyway, okay, let's go through this next one. So here now, we want to find the point at which line intersects given plane. This one's actually pretty, okay, actually I'm gonna skip this because it's easy. We have a line. This is our line. We have a plane. What do we want? The point. So this, and this, plug it into this, and this. We get the t, and then we plug the t back here to get x, y, z. And then that's it. That's it. t, plug it back in. Done. Find the equation of the plane. So this one's the other tricky one. Because here we have a point. Check. We just need a normal vector. How do we do that? Well, we get another point. So this is our visual here. The blue square, that's the plane. The green point, that's our initial point. The red thing, that's the line. And this purple, that's a line, that's a point in that line. So far, negative 1, 0. We want to get the direction vector. Why? I didn't know at first, but now I know. If we get the direction vector of that, and then we get a second direction vector, we get another vector, which is from our initial point, 3, 6, negative 1, all the way to that point on the line, that's our V2. So we want to get that point. So let's just do it. So V2 is going to be this purple point, the distance of this purple point from this green point. That's it. Like they're changing each of their components. I don't mean like their distance and length. So yeah, that's how we want to get that. So that's 4 minus 3, so that's 1. And then negative 1 minus 6, so that's negative 7. And lastly, 0 minus 1, so that's minus 1. Yeah. Yeah. So that's that vector there. Wait. Is it minus 1? I don't think so. Negative 1. Oh, wrong way. Oops, wrong way. It's actually the wrong way. It has to be going from our point to here. That way we can get that normal vector. So it's going to be 4 minus 3, which is 1. Negative 1 minus 6, which is negative 7. So visuals are important. And 0 minus negative 1, so that's positive 1. And now we can get our normal vector using that right-hand rule, I think. Yeah, that's our n, not this one. Phew. Okay, we got that. Now I wanna, yeah, you wanna do some cross products here to get our normal vector, n. So n is equal to the cross product of v1 and v2. I, j, k, negative 1, 2, negative 3, 1, negative 7, 1, right? Okay, now we keep going. Okay, so we take out the 1, we get 2, 1, 2, plus 21, because that's, huh, am I messing something up? Hopefully not. I think I messed. No, I didn't. Okay, let's just trust the process, see if it works. Yeah. Wait, let me double check real quick. So we have negative 7, negative 3, positive 21. Oh, so this is negative 2 times 1. Yeah. Next, we take out the j's. So we have negative 1 minus negative 3, so that's plus 3. And then we take out the k, so that's 7 minus 2. And so we get negative 19i 3 minus 1 is positive 2 minus 2j plus 5k. And there we go. We have our vector, our normal vector. Done. 3, wait a minute. 3, okay. Wait, oh my God. I'm messing up something so bad. Wait. Negative 1 times 1 is negative 1. Minus negative 3. 3 minus 1. 3 minus 1 is 2. What do you mean? No, I have the right values. 2. What? Okay, this is some okay, that's funny. Um okay, this is weird. Wait. Wait. 2. Okay, I got the negative 19 part. What? Negative 1 times 1. Negative 1. 1 times negative 3. Negative 3. Minus negative 3. That is the case. That's plus 3. What? Should it be minus 3 then? Minus. Why is it minus 3? No. 1 times negative 3 is negative 3. That's weird. 1 times negative 3 is negative 3. No, because, okay, I'm looking at an AI, but uh, wait. I feel like I did that correctly already, and I'm making a really uh dumb error. Yeah, it's negative 2, 5. Okay, so I was right. Okay, I was about to. Yeah, okay. GPT got it wrong. Anyways, so actually my previous answer was correct. Yeah, it was correct. Wait, let me check actually. My previous answer here was doing points. Okay, I can't, never mind. Yeah, no. Go back. The previous thing I did was I did it using points. Okay, we got our normal vector. It's fine. This works. So let's do this. Okay, now we can just find plane equation, and then that's it. We're done for this number. So we have negative 19x minus our initial point, which is this one, 3, 6, negative 1. So x minus 3 minus 2, y minus 6 plus 5, z plus 1, I think. Because this was a minus. Yeah, so it's plus 1. Now, this is equal to 0. And yeah, oh no, actually, it's negative. This is negative. This is positive. Yeah, okay, cool. Negative 19 minus 2 plus 5, x minus 3, y minus 6, z plus 1. Okay, cool. Let me double check. Negative 19 minus 2 plus 5, x minus 3, y minus 6, z plus 1. Okay, let's see if we got it. Fingers crossed, hopefully. Got it. Okay. Try to go through some of these problems more quickly. For number 6, uh, where does the line through? So this line passes through some points. It passes through this point here and another point, which is this point here. So for a line, we need a point and a direction vector that's parallel, right? We can actually find the direction vector here, just so you know. Oh, look at that. Intersect the plane. 2x plus y minus z negative 2. So this is a pretty long problem, but the idea is to find parametric equations for the line first, and then we want to intersect it. So where it's asking for a point, actually. Okay, so first thing is we want to find parametric equations for a line. How do we do that? Well, we already have our point, negative 3, 1, 0. That's our point. Now we just need to find a direction vector. So that's easy. Let's just do it. So v is the direction vector. So the difference going here and here, here and here, here and here. So this is what? Negative 1 minus negative 3. Here we go again. Negative 1 minus negative 3. Negative 1 plus 3. 2. 3 minus 1, 2. Next, we have 7. Am I doing it right? Negative 1 minus this. Okay, 7 minus this. So 7 minus 1, 6. 8 minus 0, 8. Done. That's our vector, our direction vector. We have our initial point, done. Now we can just find parametric equation. So x is a. I'm kidding, it's x naught. So we have negative 3. We added 2t. That's our x. Our y is 1 because we have 1. Y naught is 1. We added to 60. Z is 0 plus 18. Done. That's our parametric equations. Now we find point of intersection. So again, this is where you just plug in the value of x, y, and z to the plane in terms of t. So we find point of intersection of line and plane. And then we're pretty much done with the problem. So we have 2, we're using the plane, right? 2, we're plugging in our x value, which is in terms of t, plus 1 plus y minus z is equal to negative 2. And then we just solve for t here. So we have negative 6 plus 4t plus 1 plus 6t minus 8t equals negative 2. So you know the drill. We just put all the t's on one side. So 10 minus 8 2t, negative 2 plus 6 minus 1. This is what? Negative 6, negative 6. Negative 2 minus 1, negative 3. This is 3. All right. 6 minus 2 is 4, minus 1 is 3. Okay, so t is 3 over t. So that's t. And from here, we can then, so I'm gonna put like check marks maybe, just to make it like, oh, we got checkpoint. Now we just plug it in. So our x, we plug in 3 over 2. So we get negative 3 plus 2 times 3 over 2, right? Negative 3 plus, yeah. And then we get negative 3 plus 3, we get 0. For y, we also plug this in. We get 1 plus 60. So 1 plus 6, 3 over 2. So we can actually just cancel. This is 3. This is 1. 9, 10. 1 plus 9 is 10. And then we get z. So this is just 8 times this thing. 8t. 8, 4. I'll just cancel. 12. Oh, wrote it in. Why I wrote like that? Cool. 12. So that's our point. Done. 0, 10, and 12. Where does the line? Yeah. 0, 10, 12. Hit that sub. I'm kidding. Let me check first. Negative 3, 1, 0, negative 1, 7, 8. Intersect this line. Then hopefully I didn't make any algebra mistakes, did I? Hopefully not. I'm gonna bet this is correct. We'll see. Oh, we got it. Nice. Yay. Okay. Three more, no, four more problems. Yeah, four more problems. Okay. Number 7. So here we consider the following planes. For the planes, we have x plus y minus z is 3, I think. Oh no, it's plus z. Okay. Plus z is 3. And then we also have this other plane, x plus 6y plus 6z is also 3. Huh. Now that doesn't make sense. Okay, so we have those two planes. What's our first task? We want to find parametric equations. So this is a line. For a line of intersection of planes. So we do it. It's just soon. Use parameter t. Okay, we're given two planes. How do we find their line of intersection? I'm talking about their line, not a point. Can we find, so here's the thing with math, can we find some relationships? So for lines, okay, this is just me taking drafts. Let's make some general assumptions here. So we're gonna say we have nah, actually it doesn't Uh, um, yeah, we can't. No, we actually can't make any general assumptions here. Yeah, that's funny. Because I was gonna say, okay, their direction vector. Well, okay, okay. What do I need for a line? I need a point. What else do I need? A direction vector. So that's what we're gonna do. We're gonna find a point. So find the point. Okay, let's find a point, yeah? I'm gonna say, all right, any of this could work actually. Z is 0. Done. Now what do? We find x and y. X plus y is 3. X plus 6y is 3. I feel like I should have done the x. I'm kidding. I think any of them could work. Maybe, maybe. Okay, now we just do system of equations here actually. So I'm gonna put this down here maybe. I'm gonna do some system of equations here. So I'm gonna say x is 3 minus y, and so I can put this down here. This is 3 minus y plus 6y equals 3. And then I can say, oh, x equals 3 minus y. 3 minus y plus 6y. We have, I'm going to solve this real quick. So this is 3 plus 5y equals 3. And I can subtract 3 from both sides. And I got 5y is 0, y is 0 here. Done. Y is 0. Now I plug it in here. I get x is 3, y is 0. And so we have our point here. 3, 0, 0 is a point. It's actually an x-intercept. Yeah. Hmm. So that's the idea. We find a point on line of intersection. And we can say that's our initial point. Now we want to find a direction vector parallel. Find a direction vector that is parallel to line. How do we do that? Well, what's the relationship between these planes? These two planes, or a plane, if you intersect two planes, and their line of intersection. Well, if we look at their, or I think, no, oh, did I lose it? Hopefully I didn't. Anyways, okay, so if we actually look here, we can see that, oh, since L lies on both planes, it is perpendicular to both normal vectors. So if it's perpendicular to both, that means we have to get the normal vectors of both planes, right? And if we get that, so like even I can just draw it from here. That's the normal vector of one of them, so it's perpendicular. This is a normal vector for one of them. That's another one. It's perpendicular, right? So if we get if so we can actually say that if we get the cross product of these two normal vectors, we will get the direction vector for line L. So that's what we're doing, basically. I think that's how it goes. Yeah. Yeah. So we want to get the normal vectors of both planes. So for plane one, let's just do the first one. It doesn't really matter. For plane one, let's just say it's this plane. X plus Y plus Z is 3. Oh, what was that? I lost my Z. We have N1, which has 1, 1, 1. Plane 2, which is the other one, X plus 6Y plus 6Z is 3. We have N2 of 1, 6, 6. There we go. Now we want to do cross product to get direction vector. Yeah. So I'm actually going to move my head real quick. And uh, I'm going to copy and paste this part. This one's important, specifically with lines and planes in general. Or at least for this problem, it's super, super helpful. But the idea is, uh, it's just so that we can get the actual reason why this is true in this case. So here we can say, oh, we have a vector, why am I saying vector? We have a plane. Then we have another one that goes, I don't know, let's say here. Okay, now we have their line L. This means it's perpendicular to both their normal vectors. So we can say one is there, another one is here, right? And so if we get, let's say this is, I don't know, N1, N2, plane 1, plane 2. So it means if we get N1 times N2, which is just the direction vector V, let's just say V, which goes like what? Goes like here maybe? I don't know. Which I need, right? So I'm gonna do that. Okay, so to get V, N1 cross producted to N2, we get IJK, we get 1, 1, 1, 1, 6, 6. Yeah, that should be chill. Okay, now let's keep going. I, J, oops, no space. I'm gonna move it. I like to move it. Game gets stalled. Okay, so now we have I, we take out the I, 6, 6, 0. J, 6, 1. K, 1, 6. Okay, so here we have 0I minus 5J minus 5K. So we have 0, negative 5, negative 5. That's our normal vector. Or no, perpendicular to both normal vectors. Still cannot visualize this though. It's funny. Let me see. What if I go up like that? I go like that, right? Here. That. Oh, and then this one goes here, which is perpendicular. Oh, okay. That's hard. Okay, that's tricky because I'm not used to 3D. Okay, that's fun. Okay. Now we have our direction vector, and we have our point. Done. Now we just find parametric equations. So this is x, which is my x naught, so 3. And then the rest is 0. So 3, ooh, 3 plus 0t. Okay, that is sus. Y is 0, so this is negative 5t. And z is negative 5t again. Is there something wrong with my initial point? Maybe. Maybe. I'm not super confident with this because x is just x naught. But hey, I mean, it's in the point, so it must be. Because I could have also chosen like what? Like y is 0 maybe. So it would give a different one. I don't know. Not super confident with that. So we're gonna quickly check what that looks like. Oh, okay. So I did mess up some parts, maybe. Uh, we wanna find a solution. Okay, what GPT did was it found like a general solution to the system. And then got some values out of it. Express variables in terms of what is this? 5y plus 5z y is equal to negative z? Question mark? Okay. And then what happened here? We expressed variables in terms of parameters. So z is t and y is negative t. Now I plug it in. Huh. Yes. Man, that's something. So it's actually one of these points that made it super tricky. Yeah, because we wanna what did here is it solved for something general. That's what it did. So I'm gonna do that. But still the idea remains the same. We want to find the point and we want to find um some things here. So well, since we know this is 3, right? So we have this system here. We have this system here. We have x plus y plus z is 3, x plus 6y. I mean, at first glance, this looks already weird because of the 6 part, right? And we can actually subtract these, and it will give me this thing. Subtract the other equation, and then this is just 3 minus 3, which is 0, right? And then we can actually further simplify this thing. So we got like what? X minus x plus y minus 6y plus z minus 6z, which is 0. And then we got something else. Um, Actually, this is funny because we should have done it the other way around. So this is 6y, 6z. This is the one with the y and z. I think any of them could be fine. I'm actually not sure. So 6, put the 6 here, put the 6y here. And then here as well, put the 6z here. Okay, now we have 5y plus 5z is 0, right? And now we can actually just divide it. So we have like y plus z is 0. And so we have y is negative z. Okay. And then if we want to express it in terms of the parameter, so since we got, I mean, yeah, y is just here y is just t and z is negative t. Oh shoot, it's the other way around. Oh my goodness. Okay. Z is t, y is negative t. Okay, that's inverted, but it makes sense. Like it works, right? Z here is t, and then y is negative t. Like that works. That works. And now x is just 3 if we plug it in. Yeah. And then from there we get um we don't even need to do this part because we already got it from here. Oh my. Oh shoot. Okay. Uh yeah, so this is going to be it's just this. This is it. Like we were able to find it just solving the system. So it's one of those tricky ones. Yeah, I didn't need this because it wasn't general. That's the problem. So whenever we have general cases like this, we might as well solve the system. So that's the idea. If we're given two planes, we just solve the system and we get it. Yeah. So x of t is always 3, y of t is negative t, and then t for z of t. Um, yeah. Oh my goodness, there's a video. I could have watched the video. Okay, I should have done that. Let me just quickly watch this. Okay, we got their normal vectors. So do I do a cross product? I'm just watching the video. Oh, wow. Okay, wait, let me actually redo it. Yeah, I think I got it this time. Or I should be able to get it this time. So it's actually the same idea. We again want to find, I don't want to do it this way. We again want to find, um, for a line, we need an initial point and we need a vector. We can actually find the vector already. Actually, we already did it like a while ago. Can we get that back? Oh, we got it back. Nice. Okay, so we did get it back here. There we go. So we can actually find the direction vector first. Let's do that. Can we do this? Okay. So I'm gonna put these first because at least I'm confident that we got this one. Cool. Okay. I'm gonna put it up a bit. Yeah. So all of that was to find a direction vector, which we got. It's not this one. We have the five. That's the issue. Yeah, we did get their normal vector here. There. And now the next thing we want to do is we want to find some point on the line. So we can actually just let Z be 0 and then just be good to go, right? Yeah, I mean, we got this part. We got this part. 111, 166. Okay. Uh, yeah, and then now we did like what? I, boom. 6, 6, done. Minus, because of the, yeah, it's because of the sixth part. Uh, Here it's also because of 2, right? I mean, if we take out the I here, that's weird. Yeah, I mean, we should get it. It's funny. Now we just find a point on the line. I feel like I'm losing confidence, but I shouldn't be. So we just have to find point on line of intersection. And then here, let's just say what, like Z is 0. So here we just, yeah, let's just do that. I'm gonna be confident and let's just do that. So we let Z be 0. If we don't get it, that's fine. If we get it, cool. Okay, now we let Z be 0. Now we can use these equations. X plus Y is 3. What else do we know? Uh, X plus 6Y is also 3. And if we actually solve for these, well, we will get X is 3, Y is 0, right? Yeah, we're gonna get that. Yeah. Uh, I'm trying to look at his example. X plus Y, X plus 2Y. We can try X plus Y, X plus 2Y. They're both equal to 1, right? Now I can just do this. 1 minus y. I can say 1 minus y plus 2y. And I can say, 1 plus 1, y is 1. Oh, okay, y is 0. I can do that. And from there, I can say, oh, x is 1. So that method works, the method I did earlier. So yeah, x is 3. Let's see if it works. 3, 0, 3, 0. Yeah, it works. It works. So our point is just going to be this. Now we just plug it in. Oh, that's it. So we just find parametric equations. Yeah, we already got. I wasn't just confident in myself because of GPT. So we have x naught, so 3. This is 0, so no, right? Y, 0, so negative 5t, done. Z, 5t. That's it. Oh, wait a minute. I get double negative here in this case. Did he get double negative? Oh, no, he didn't. So I messed up somewhere. Yeah, I shouldn't get a double negative. Let's try. Let's try again. Take this out. So we have 6 times 1, 6 times 1. Subtract. Done. Minus j. 1 times 6, 6. 1 times 1, 1. This is correct. This is correct. And then I do j plus. I think this is the issue. 1 times. Oh, so it should be the other way. 6 minus 1. No, you got 5 here. Yeah. I can take this out. And then, yeah, I got 5t there. There, that's it. Oh, I'm gonna use that. Put 5. Just use a bit more quickly because I need to. Okay, boom, done. Okay, now here we find the angle rounded to 1 decimal place between the planes. So let's do that real quick. Find angle in degrees. Between planes. Okay. So what is this? Well, I don't know. I can't like find it in one go, maybe. Oh, we just get their normal vectors. And then I get their dot product. Okay, yeah. Yeah. I just have to get their dot product, yeah. So to find the angle, we wanna get hmm, we wanna get their normal vectors, which you already did actually. It was here, there. Really got. So I'm just gonna copy and paste those. Oh, what? Oh, it went. Okay. Now we have their normal vectors. Now what do we want to do? We want to use dot product to find angle. So I'm just gonna do what? The dot product of n1, n2, which is the length of both vectors, cosine theta. And now I just do their dot product right here. So let's do that real quick. So it's going to be 1, 1, 1, 1, 6, 6. We got 1 times 1 plus 1 times 6 plus 1 times 6. We got 6, 6, 1, 12, 13. Right? 12 plus 1, 13. We got, okay, the magnitude of n1 vectors. So this is square root of 3. Just complete the solution. Why not? 1 squared, 1 squared, 1 squared. So we get square root 3. Then we have n2, which is 1, 6, 6. So 1 squared, 6 squared, 6 squared. I get like what? Double 36. So 72 plus 1, 73. Okay, now I just plug in everything. So 13 dot product is square root of 3, square root 73, cosine theta, which is just 73 times 3. So that's 219 cosine theta. And then we get theta is our cos of 13 over this 219, which is approximately in 1 decimal place. So I'm just gonna use my calculator. Square root 219. It's in degrees, and I got 28.5. So that's that. Let's just hit that. Hit it home. 28.5. It's good. Next, 3 more questions. So here we find equation of plane. Okay, so this plane passes through point. What is this point? 4, 2, 3. What else? And contains line of intersection. Of planes. So we're actually given 2 planes here. X plus 2y plus 3z is 1. So that plane and another plane, 2x minus y plus z is 3 is -3. Okay, now how do we do this again? Well, we have a point. Check. Now we just need to find a normal vector, n. And actually, we can kind of see this. We have that plane, this plane. The line of intersection here, right? Now, we want to get their normal vector. So we want to get the normal vector of this thing and this thing. Not because of this angle, but because from what we previously discussed. If L lies on both planes, it is perpendicular to both vectors. It's that idea that we want to use, right? So once we get n1 and n2, which is equal to this vector here. Yeah. Wonder why we need that again. I'm actually, wait a minute. Okay, let me check the previous examples because I'm lost. I'm actually a bit lost. What's that problem with the two planes again? Uh, okay. Yeah, I'm gonna admit this is really tricky. Oh, this is different again. Oh my goodness. Okay. Line of intersection of planes, right? So we have these line of intersection. We have two normal vectors. We can't, that's tricky. This is really tricky. Um, contains. I can't tell, to be honest. I actually can't tell. Okay, wait. If I, oh, I can watch the video. I give up. What is it? Like, how do we do this types of problems? Okay, okay. What about their normal vectors? What happens if I get A? Happens if I get A? Oh my goodness. So now we're connecting everything that we just learned. Once we get that vector that's perpendicular, if we get the cross product of the two normal vectors of the two other planes, we want to get another vector and then do another cross product on that to get the normal vector. And then we can write down the equation of the plane. This is crazy. Actually crazy. Wait, actually, what if we, okay, let's say we find that A, right? Let's say we find that direction vector there. Now what? How do we find the other one? Well, the other one is going to be, holy smokes. Okay, so, okay, I'm running out of time here. Okay, let's see. Once we get A, okay, let's take it step by step. Let's take it slow. And then we get B. But oh, we plot a line, we plot a point. So I need to find a point. Okay. I need to find another point. So that's the idea. Okay. I'm gonna do this and then we're gonna stop from here and I'm just gonna do the rest on my own. Okay, so let's actually do this, yeah? So like the first thing, so that's the idea. We have our point, now we want to find the normal vector n. Well, we want to get n1 and n2, right? So n1 is this thing. 1, 2, 3. Done. N2 is this other normal vector of this other thing. So 2, -1, 1. And now we want to get their cross product to get the direction vector of the line of intersection. So V, or let's do A actually. A, because in the video it did A. So we want to get their cross product here. I, J, K. 1, 2, 3, 2, -1, 1. And then this is going to be, well, let's just do it here. I, actually, screw it. Cross out the I. So what do we get? 2 minus -3. 2 plus 3, I minus. Then we do the J this time. So we have 1 minus 6, 2 times 3. J plus, and then we have K. So for K, -1 minus 4. Okay, there we go. Now we have 5i minus -5. So minus -5. So plus 5j minus 5k. And so we have this vector here. 5, 5, -5. Done. Now we have vector A. That's one vector. Now we need another one and then get their cross product. So let's do B. Here we want to find a point from the line of intersection. That's what we want to do. So let's say let x be 0. I don't know. So what happens if x is 0? Well, 2y plus 3z is 1. And then we have another solution here, which is y plus z is -3. And then I can just plug in one of them. So I can solve for y and z. So y is -3 minus z. And then here I can say 2 -3 minus z plus 3z is 1. This is minus 6 minus 2z. And then this is 3 minus 2, so that's positive 1. -6 plus z equals 1. Now I can just put it to the other side. So this is z is 7. And I can plug it in here. So this is y is -3 minus 7, -10. Okay, now what do we do? Now we can, we actually have a point now. So our point is 0, -10, 7. And from that point, we want to find a direction vector VB. Oh my goodness. Okay, so for direction vector B, we want to find the distance from this point that we just got to here, our initial point. Yeah, so let's do that. It's just difference in components, to be honest. So it's from here all the way to here. So I have to subtract this to here. So 4 minus 0 is 4. Uh, 2 minus negative 10. So it's positive 12. Because that's just 2 plus 10. 3 minus 7. Ooh, almost. Negative 4. Done. Now, once we get that, we want to get their cross product again to get the normal vector. A lot of cross products are coming into play here. 5, 5, negative 5. 4, 12, negative 4. Let's do it again. So we have, what's this? I, take out the I. Negative 20 minus, what's this? 12 times negative 5? 60. Minus 60 says plus 60. I. Now we take out the j's. Minus 5 times negative 4 is negative 20. This is plus 20, right? Because minus 20. So we get that for j. And lastly, for k, we get for k, we get 12 times 5 is 60 minus 20 per k. And so we get basically 40, 60 minus 20 is 40, 0, and 40. So 40, 0, 40. That's our normal vector. And now we can just find plane equation. And then we're done. So plane equation here is just 40 x minus the initial points, or the initial point. So x minus 4, I believe. X minus 4, 0. So it means we don't have a y. So we go again, 40 z minus 3 equals 0. That's that. Okay. Yeah, so that's it for this video, and I'll see you guys in the next one.